All right, good afternoon. Let's go ahead and get started here. And my next button is not doing what it should. There we go. Okay, great. So anyway, my name is Chris Hallam. I'm a Senior Product Manager for Windows Client Security at Microsoft. So my area of responsibility is anything that has to do with the client operating system when it comes to technologies to help secure it. Kind of goes down to the hardware level, although the hardware is owned by people like Intel and whatnot. But I have to speak on things like TPM, UEFI, etc. But things like Bitlocker, App Blocker, Trusted Boot, all those things that we do in software to keep the client secure, that all comes under my domain. And so our topic today is kind of an overview of Windows 8.1 technology, but it's really the whole story. It's everything that's kind of new in 8 and 8.1, so it's kind of a concatenation of both. And I'm going to kind of emphasize the TCG connections that we have as we go through the content. But before I get into the details, how many of you are familiar with Windows 8 security technologies so far? I'm trying to figure out how much I should do on 8 plus 8.1, or should it be all about 8.1? So who wants all 8.1 and really very little on 8? Okay, who wants a little bit on 8? So it looks like we can mix back. So what I'll do is I'll kind of do a little bit of both, right? So nobody gets shortchanged. So let's go dive in here. So we have a lot of content to cover, by the way. So this is going to feel a little bit like a fire hose potentially, because I want to give you a lot of information. So I'm not going to do questions, and the reason why is I'm going to be sitting back there right after this and all day tomorrow, so I can take questions then. Maybe we can get some at the end. But I want to make sure I can give you as much information in the short time we have. So let's dig right into it here. So let's start with a little bit about the history of security in Windows, and then kind of how things have evolved over time. So if we start back in 2001 with Windows XP and we move into 2004, you'll remember within that time frame we had a big aha moment when it came to security. We had Code Red and Slammer, all these things that told us that Windows is not ready for today's threats, those threats that were modern at the time. And so XP-SP2 dealt with a lot of those challenges, but we did everything in software. So every solution we delivered was a software solution. A lot of those were very effective. I think that XP-SP2 was really good at its time. Right solution, right time. We wish it could do more, but it was all software based. But as we move into the future, into more modern threats, we start to see a need to do something beyond just software. If we look at Vista, not a commercially successful operating system, it wasn't what we wanted there, but you know what, from a security perspective, all the right decisions I think were made, right? The architecture that was built there exists in many respects today. So it was the right platform security-wise, but I think there was more work to do. When we move into 7, of course, you'll see we added more security technology. With 8, we add more and more and more. And so what we've done from Vista on is, we really kind of turned the aircraft carrier. It's like, hey, security is a top priority. And we continued to increase the total staff working on security so that we could add more and more. And so Windows 8 actually represented the largest release from a security technology perspective that we had ever done. And some people have characterized the volume of new capability there as being equal to everything we did between XP and Vista. So if you think about one OS hop between 7 and 8 is equal to everything prior to that in one release. That's how much. And it's no surprise because our security team is huge now, comparatively. So we were able to get that. But this became also kind of the era of needing hardware to help us. We can't just solve problems in security. We need hardware. And you'll see in 7, we use TPM, Vista TPM, 7 TPM, 8 TPM and UEFI. So we continue to add more and more security hardware technologies into our security story, and we look forward to adding more as new hardware technologies come out. So we believe very strongly that security really is marrying hardware and security, software security together. So when we look at the capabilities in Windows 8, we organized our effort around 3 key pillars: malware resistance, protecting data, and access control. So that's kind of our mental model on how we approach security. And if we were to go through some of the key benefits we had when it came to malware resistance, one of the big features we added there is basically boot protection, right? In Windows 7, boot kits, root kits, these types of things. Difficult to do, but if you find the right zero-day, you can very easily deploy a boot kit to that PC that will remain undetectable for maybe forever. So that's a problem we wanted to eliminate. And so with Windows 8, with technologies from the TCG, such as UEFI, plus some other things we did with Trusted Boot, etc., we were able to basically kind of eliminate eradicate boot and rootkits from Windows PCs on 8 and beyond. When it came to securing the code in the core, we did a lot of work there. I mentioned the right vulnerability a moment ago. Well, it was pretty hard to exploit a vulnerability on Windows 7. It required the right talent. In 8, it takes really a magnitude of order more IQ to be able to exploit the system now. We've made investments in ALSR and depth. They're applied more broadly across the system, and the level of entropy that we have in ALSR, as an example, is many more times what it used to be. It goes from like 8 bits to 32 bits of entropy, depending on what part of the system we're looking at. So a pretty dramatic improvement there. When it comes to securing the desktop, we have a lot of other technologies that we just don't have time to go into, but we did some pretty cool things there, things like smart screen improvements, ELAM, for instance, which is early load anti-malware, the ability to keep your anti-malware solution healthy and protected from malware. That's an improvement we've added in 8 as well. When it came to protecting sensitive data, our goal was to make Bitlocker the easiest to deploy encryption solution. We also wanted to make sure that we could leverage new technologies, and another example would be TCG technology, which would be encrypting hard drives based on Opal specification. Those are now supported in Windows 8. Now, we need to be really clear about which drives we're talking about here. If you find an SED, a self-encrypting drive, that's not what we're supporting on Windows 8. We're using encrypting hard drives. They're a new drive. You need to be careful about what you're looking for out there, but they're not SEDs. They're encrypting hard drives, so look for those by name. We have some work to do with the IHVs about making sure that they're marketing that way, so you can make the distinction between SEDs and EHDs, if you want to call them that, because they're not making it really clear, and so we're giving them some feedback on that. So be careful about your purchases. SEDs behave like traditional disks on Windows 8, and you need EHD. Last area here is modern access control. When it came to sign-in, passwords, as many of you know, are really a thing of the past. We need to move as quickly away from passwords as we can. We can't turn a switch in Windows to get rid of them because they're deeply embedded in your systems. But virtual smart cards is a great example of you being able to move away from a password to a two-factor authentication option. In this case, it's based on a certificate and a PIN, but it basically turns your PC into a walking physical smart card. So you're able to move away from passwords with Windows 8. And that uses TPM as a way to secure that certificate that's provisioned to the device. And we could go on and on about more access control pieces, but when it came to this whole story, much of it is built on these TCG technologies that we're here to talk about. So things like UFI and TPM are central to our story. So let's talk about kind of some of the basic success that we experienced on 8 since we've released. So the big hero of the release was Malware Resistance. If you looked at the head count working on that particular area, where's the biggest investment, it was basically making sure that Windows 8 is resistant to malware. And so this information comes from the TCG, or not TCG, but the Trustworthy Computing Group at Microsoft. They publish a report, the Security Intelligence Report, and this starts right out of version 14, which I think came out in the summer. But the thing that's interesting here is in the chart you have basically per 1,000 machines, and then you have the infection rates across a variety of different OSs. So if we animate here, you'll see on Windows 8 RTM, that's on 64-bit OS, that 0.2 per 1,000 PCs will have some sort of infection that we're able to detect from the telemetry data that's sent to us by our customers. If we compare that versus 7, you're seeing 6 times improvement between 7 and 8. So when it comes to malware resistance, you're 6 times less likely to be impacted by malware on Windows 8. And so the question is maybe why. I would suspect, we don't have the data to prove this, but I would venture to guess that things like our improvements in ALSR, making the system less vulnerable to attack, things like UFI, which can prevent bootkits from persisting, Trusted Boot, which prevents rootkits from being able to persist, I think have impacted these numbers, right? There's probably other factors as well. There's improvements in smart screen and other things, but there's a pretty big difference, 6 times less likely to be impacted. If we compare it versus XP, it's 21 times. So huge difference versus XP. So if you have any PCs in your network that are running XP, here's a great proof point on how much better off you'll be when you move to the new OS. But let's not belabor that. Let's kind of move into kind of Windows 8.1 thinking and what we're doing there. And so we really believe that there are, and I bet you a lot of people agree with this, by the way, is there are really kind of 2 organizations out there, right? There are those who realize they've been hacked, and they admit it, and they've maybe disclosed it publicly, and then there's these people who probably just don't realize it. We believe that's true in most cases, and I think a lot of the stats you look at out there, if you look at the Verizon data breach report, they estimate that like 70% of small businesses have been infiltrated. And that's just based on customers saying, yeah, I got hacked, right? So 70% of people are saying that they got hacked, and then those 30%, my guess is a large subset of them probably have been as well. So that's kind of where I think we are, and that drove a lot of our thinking for Windows 8.1. And there's these familiar threats, right? So we've been talking about threats for many versions of Windows, and the threats are very familiar, right? Oh, we got bootkits, we got rootkits, we got this type of malware, it's polymorphic. It's all these different things, right? These are old familiar things, right? And there's new ways of doing these things, but they're pretty familiar to us. But we really believe we're moving into a world of modern. And modern is a world where it's not just about malware. There's new vectors of attack. We think that social engineering, which is kind of old, but we think that that's really where a lot of people are focusing their energy. It's much easier to hack the human now, I think, than it is to hack on Windows 7 even, and especially so on Windows 8. We won't be free of malware, but we think social engineering is how people are going to steal identities. And so if we compare the modern versus the familiar, we're familiar with cybercrime, but now it's espionage and cyber warfare, right? Very different types of people behind these types of attacks, right? We're familiar with script kiddies, right? They're doing simple things. They're working as individuals. Well, now it's state-sponsored actors, potentially, right? Very likely, in fact. We have software solutions that we talked about. Now we need hardware solutions that work with software. We're familiar with securing the perimeter, right? If I put a wall around my castle, it's good enough. Well, now you know they're getting inside, right, based on what we talked about earlier. And so you need to protect everything within it. Every single resource has to be protected with some sort of level of access control. We need multi-factor authentication, on and on. We're familiar with attacks on Fortune 500, but guess what? If you're a small business, and I know that doesn't include the people here probably, but if you're a small business is doing business with a large business, you will be targeted specifically because you probably can give them insight into the real target. So if you build nuts and bolts for Lockheed Martin, you will be targeted because they know that you have information that might be useful, that maybe helps you get inside Lockheed, just as an example. We're familiar with company-owned and tightly managed devices, but now we have random devices. We were talking earlier today about devices that are not as secure in some respects as Windows by default, right? That don't have security solutions you can even deploy to them, being allowed onto your networks with nobody even asking questions in some cases. So it's kind of the Wild West. And then we're familiar with hoping you don't get hacked, but we need to, in the modern world, assume it's inevitable. And so it's about limiting the damage. So here's a couple of quick quotes, and then we'll get into some meat here. This is from F-Secure in response to the Flame virus, which you're probably familiar with. The short story of what they're saying here is the security solutions that you've deployed in your network are not designed to protect you against the digital equivalent of SEAL Team 6. So I'm sure everybody in this room has heard of SEAL Team 6, and if that's the attacker that's coming after you, they're going to win, right? Because that's what they do. So you need to think very differently about who these attackers are. They're not script kiddies using recipes that they can download from the internet. These are very sophisticated people. This is from the Verizon data breach report. Just kind of emphasizing what I said earlier. If you think you're too small to be a target, you're absolutely wrong. If you've ever swiped a credit card, just one, you're going to be a target because that credit card info is useful, and there's a prolific black market for selling them, right? So even a small business selling cookies, right, out of their home is going to be targeted because they've got credit card information that is useful. And actually, when we bring that back to passwords even, they know that if you set a password on your account at the Cookie Club website, that's very likely the password you use on Amazon and Facebook and all the other websites. So they know that they can compromise that. They own all your accounts, maybe your Fidelity account, your banking account. So very different world we're in. Last quote here, this is a little more recent, this came out this summer. This is where Lockheed Martin talked about how much money they're spending protecting their supply chain, right? So these small businesses, the people supplying nuts and bolts, they are spending more money protecting those people, their vendors, their contractors, their supply chain, than they spend protecting their own company, according to this quote. So very, very interesting, a new modern world. So let's talk about what Windows 8.1 is going to bring to bear on this. And so what you can see is we've added another thick layer. I'm not going to dwell on this slide on the individual things, so we have slides that follow that cover it. But Windows 8.1 is a very significant release when it comes to security. And there's some things that we think will address what we consider the modern threat, which we think is maybe not so much malware. Right? We know that that's still a problem and we continue to invest there, but the big hero for this release is what we're doing in modern access control, things that we're doing to protect identities, etc. And so let's dive into that. So, of course, all this starts with trustworthy hardware. That's one of the things we've been talking about all week. And there's two technologies, of course, that Windows leverages. There's UEFI and TPM. I expect that most of you already know about UEFI. From a Windows perspective, it provides all sorts of benefits, but from a security perspective, this gives us a secure way to start up an operating system. Could be Windows, could be another Linux distribution, but this creates a condition where malware can't get in between the hardware and the desired bootloader, right? So this is great. This means no more bootkits on a PC unless you're able to compromise UEFI, or if you're able to maybe compromise the signatures of that are used to sign the OS loader. So pretty difficult to compromise this system, but it's not bulletproof, right? We assume that our signatures have integrity and that they've been secured. But anyway, so UEFI, secure boot, is really the big feature. From a TPM perspective, of course, we've used that traditionally for Bitlocker. Most people know TPM is a Bitlocker thing. But in Windows 8, we added all sorts of other features that are taking advantage of TPM. We have things like virtual smart cards. ALSR entropy is better when you have a TPM in the PC. So if the TPM is there, you're going to have better randomization or entropy in system memory. We've done a number of things. In 8.1, we're doing a couple of things. We're adding a new feature, which I'll talk about a little later. But the big thing is we've made a decision in the 8.1 timeframe, although this doesn't go into effect until later, that 2015 will be the beginning of an era where every Windows PC ships with a TPM. So it could be discrete, could be firmware based, but starting in just a little over a year from now, every single Windows device is going to include TPM. In 2014, we're going to see many devices include TPM, including consumer devices, because of technologies like platform trust technology from Intel. AMD has an equivalent. I don't recall the name, but they have the ability to include firmware-based TPM solutions on those devices. So we're going to start seeing TPM trickle into consumer devices. It's already happened in many respects, even with 8, because our tablets, which we used to call connected standby, which is an architecture, we now have rebranded that to Instant Go. By requirement, they have to have a TPM. So TPM is incredibly important for these mobile devices, and so we've made a requirement. But anyway, so things are getting very good for TPM in the next 18 months. It will become pervasive all across consumer enterprise. So let's drill into modern access control here. So we divide our investment areas into these three kind of topics here. We have modern authenticators, trustworthy identities, secure access to resources. When it comes to authenticators, we have a number of things here. When it comes to CCG technologies, virtual smart cards is a technology that maybe some of you know. A lot of you maybe don't know this yet, but basically what we're able to do is you're able to provision a certificate to a PC. That PC then can be used for authentication. We virtualize a physical smart card on the device. So if you go into the device manager, you'll see a reader and a card. It's always inserted. It leverages the TPM, and your PC itself becomes the second form of authentication. So this is a pretty cool thing because it's electronically provisionable, but it's important to know that this is two-factor auth when that device connects to a remote resource, but when you sign into Windows, it's really single-factor, right? You're using a PIN to log in because the device always has its smart card inserted. So there is something to think about there. Now there's some things that we might be able to do in the future to make that virtual smart cards a true two-factor authentication. I'll let you speculate on what those things are, but there's some things we're exploring for the future to make virtual smart cards a true two-factor authentication option in all scenarios. So virtual smart cards are a great thing. With 8.1, the big investment area was biometrics. So again, our goal is to eradicate the password with Windows 8. We give you virtual smart cards. That helps you get there to a certain extent. But even that is not great because you have a PIN, right? You have to remember this thing. Fingerprint biometrics would be a better solution because then you're using your biometric identity, which is something that somebody can't steal from you very easily. And so biometrics is a big deal for this release. We're optimizing, though, for fingerprint-based biometrics. So you can use facial, palm, all sorts of different options, but most of our investment is in fingerprints because we believe that the sensors for these can be delivered on all the mobile devices that you'd like to see them on, phones, tablets, and also traditional PCs that sit on the desktop. So we think it has the broadest application. We believe that it's cost effective, and we also believe that with the right technology, it can also be very secure. There's been a lot of discussion about whether fingerprint sensors are secure enough, and there's always a story you can find on the internet about somebody spoofing a fingerprint. The technologies that they're almost certainly using in these cases are optical technology. So think of optical as a scanner, a photocopier, and it's basically an image of your fingerprint. It doesn't have the concept of it doesn't have a three-dimensional view. It doesn't have the concept of liveness, meaning the ability to detect maybe a heartbeat and detect the difference between rubber and maybe flesh. There's all sorts of technologies that modern fingerprint readers that include liveness detection can do to make them very, very difficult to spoof. So fingerprint readers, if it's the right ones, are very good. If you see some Lenovo laptops here in the audience, they have a swipe sensor. And so swipe sensors have been out for a while. They're kind of difficult to use. You swipe your finger across it, and if you have your finger at an angle, it probably doesn't read it the first time, so you correct and you do it a second time. Maybe it takes a third time. They're a little tricky to get them to work. A modern reader not only has liveness detection, it also has a concept of touch. So there's a new line of touch-based sensors that are available in the marketplace today. There's new ones coming online as well. They're very expensive. Typically, they're about $100, $150, even $250 for these touch sensors. The prices on these are going to go down to a very low price point, to a point that where OEMs are going to find it attractive to put these in PCs. So we expect in 2014 Windows PCs shipping with touch-based sensors, which are superior. They're very easy to use, etc. We believe that's going to happen. In fact, I think maybe today, if you follow what's going on with Apple, you'll probably see some interesting things with the Apple phone. I'm sure that might include a touch-based sensor. So, and I believe Android devices will be having those. So we're all kind of moving together, regardless of Apple, Microsoft, or Google, moving in the direction of fingerprint biometrics and touch-based sensors. If we move into the middle here with trustworthy identities, there's a couple things that are interesting. One of them came from Windows 8, and I was told earlier today by one of our customers here that you guys have not talked about this enough. So key protection. So there is a TPM KSP in Windows 8. We're able to bind certificates provision to the devices. Yes, you let me know that we weren't marketing this enough, but this audience obviously be interested in this. So anyway, the ability to basically bind the certificates on your PC to the PC to prevent things like Mimikatz hacks, where you can export the certs and replay them elsewhere. We've broken that scenario with this technology, and that shipped in Windows 8. But we're taking it to the next step with Windows 8.1. While it's nice to be able to lock a certificate to the PC and bind it when a PC is connecting to our network resource, wouldn't it be great if that network resource could say, I'll let you use this identity, but you have to prove to me that it has been protected by, securely provisioned to a device and secured by a TPM. Right? So now we can make sure that the whole round trip from provisioning to the PC that attempts to use this as an authenticator, that's been secure, that entire life cycle, if you want to call it that. And so our feature TPM key attestation gives us capability and now allows us to basically have an access control scenario where we can deny access to PCs that have maybe seemingly legitimate certificates, but maybe they haven't been securely protected. So this will be particularly interesting, I think, especially for government sector, and anybody actually might take advantage of this, but I know government probably will adopt this first. Another thing we're doing is certificate reputation. So as you go onto the internet and you go to Microsoft.com or Google or whatever, and you receive the certificate that represents the identity of that site, you'll trust that identity has been secured, especially if the browser says it's green and everything's good to go. Well, as we've seen in the past, there's been some famous compromises of certificates where real certificates have shown up on illegitimate servers, and we've seen attacks on DNS where we could redirect traffic to these hacked up servers, and now we're stealing identities and doing these types of things. So what we're going to do, and this actually benefits not just Windows 8.1 customers, but even Android users and Apple users, is we're adding a certificate reputation service where we will basically be harvesting the public keys from websites. We will be storing those, and we will also be looking at where these are being provisioned from, and if we see anomalies in the use of these certificates, in the delivery of them, maybe even within them, meaning we have the ability to analyze that certificate and look deeply within it. If we see any anomalies, we can initiate a process that may result in remediation, which might be revocation of a particular certificate. So if we see Google's server suddenly showing up in some strange place with a certificate that maybe looks right but it's not, we can contact the CA, and the CA can then discuss this with Google, and maybe that can be revoked. Today, Google probably is protecting its own certs, but this is a solution for everybody on the internet. So this is great for everybody. Oops, I actually skipped forward. Let me go back. Last area here is access to resources. So we have a technology called dynamic access control. This allows you to move away from static security lists where you constantly are adding and removing users who have access to certain resources. That's a very labor-intensive process. We now have a means to leverage Active Directory properties, and thus you now have dynamic access control. So rather than using a static list, you leverage a user's properties in AD, such as what department they're in, maybe their security clearance, maybe other properties might have an AD, and those are used for access control. So you can imagine a scenario where I'm a member of the finance department from the United States, and I want to access U.S.-related documents. I can use dynamic access control, which can then determine, okay, what department is that person in? Are they in the United States? Who do they report to? Should they have access to finance docs, etc.? And they automatically are provisioned access effectively. And what's nice is, unlike what you have today, where actually, let me give you an example instead. I recently made a change in my role at Microsoft. I came from the engineering team a couple years ago, and I had access to all the engineering docs, right? I moved into product management role, which is outside of engineering, right? What I had to go through is I had to call people and find out how to get access to all these resources. They had many security groups. With dynamic access control, the fact that I changed my membership on who my direct reporting manager is in the department, that actually could have gave me access immediately to those new resources rather than somebody having to do that heavy lifting to add me to a security group. So dynamic access control kind of works automatically. It's a rules-based system. The last area here is remote attestation. Remote attestation is a very interesting thing for us. Windows provides a number of resources that will be useful to the remote attestation, but Microsoft does not deliver a remote attestation service. So we have capabilities like measured boot, which takes boot integrity measurements. We have instrumentation, allows you to determine the health of an FM malware solution, the state of policy, security configuration, etc. All that information can be harvested, but we need another service out there, a remote attestation service, to analyze that remotely. And that can be combined with access control capabilities where if a PC is infected, for instance, maybe there's some low-level bootkit that maybe has somehow compromised one of our signatures, right? And it looks like a Microsoft OS loader, but it's not. Remote attestation service could detect that potentially and then could then create a condition where that device was denied access to resources on the network. So we look to companies like Wave Systems has remote attestation service, and a number of other people, a number of SIs are building this as well. But there's some prepackaged product out there, but there's also a lot of SI solutions out there as well. So we think that this is the future. Anyway, it's going to be great to start seeing some case studies come out of organizations like yours where it's being actually used. So these are the technologies here that would take advantage of TCG technologies, virtual smart cards, TPM in the middle there, remote attestation, TPM. So a lot of use of TPM. I think UFI also comes into play in some respects here, but TPM is the main player on those ones that are highlighted there. So let's move into malware resistance, another area. So lots of things have gone on in this area, most of which happened in 8, but we've got a couple things in 8.1 that are new. SDL has kind of reached a very, very mature state, security development lifecycle. If you're familiar with the Kaspersky report, Microsoft products are no longer in the top 10 list of products with vulnerabilities. And I think that the maturity of the SDL has gone to a place where our engineering practices gone to a place where we have the most secure we've delivered yet, or the most secure code we've ever delivered yet. So we're pretty proud of the accolade there. But what we know, though, is we have human beings writing code. That'll probably continue for a little while longer. And so we do need technologies to mitigate against vulnerabilities. And so, as I mentioned earlier, ALSR and DEP have been improved and are used more liberally across all of Windows now, as opposed to certain portions. So we've made some big changes there. We got some great quotes here from Chris Valasek. Many of you probably recognize his name. He just kind of says what I said earlier, which is, the advancements of Windows XP to 7 are leaps and bounds. The advancements to 7 to 8 are basically the same. So another thing he said, it didn't fit on the slide, is he said that he would not want to be tasked with writing a heap exploit on Windows 8. And it's because of the improvements in ALSR and DEP in particular. So Chris Valasek's really good at hacking. That's kind of like his job. So for him to say he doesn't want to be tasked with that tells you a lot about how much the game has changed on 8. When it comes to securing the boot, I think you're familiar with most of these things. We have UFI giving us a secure boot. We have trusted boot protecting the rest of the boot process. This prevents rootkits from being in there. I mentioned ELAM, which allows us to protect the anti-malware solution. We do that. ELAM actually is really considered a subcomponent of trusted boot. ELAM basically is a socket for the anti-malware solution to insert a driver. That driver is protected by Windows and the trusted boot process, and that basically bootstraps a secure startup of the anti-malware solution. So all of this then, of course, all points back to UFI, right? When you have UFI, you have that chain of trust where you know these things are going to work. On a Windows 7 PC, without UFI, you're still better off. But you could have a bootkit that could be compromising everything else on the PC. So I think you really need Windows 8 certified hardware with UFI to really get the full benefit, but you will be better off than you are even on with 8 on 7 devices. The last piece here is measured boot. That's the component where we take integrity measurements of the PC, and that can be used for remote attestation and other types of scenarios. So let's move into our last area here, securing the boot. We've got Windows Defender, of course, which is a now in-box anti-malware solution. It's rich, feature-rich. It's a compete with McAfee and Symantec, etc. So unlike what it used to be, which is spyware anti-malware solution, it's a full-fledged anti-malware solution. This next feature here, Windows Store and Apps. So the store is great in that you now have applications getting vetted and they end up in the store. And so those, in theory, give you a much more secure way of getting apps, much better than going to random websites and downloading content. But I think the real innovation with the Windows Store is really the app container that those apps live in. So on Windows 7, you have a desktop, and those desktop apps have access to all sorts of different system resources, potentially everything on the system, right, depending on the level of access that process is running under. With Windows Store apps, they sit in a sandbox that we call an app container. This is similar to what you see on iOS, you see on other mobile OSs. And so this is great, right? You now have a situation where these apps, even if they have defects in them, even if they have vulnerabilities, there's another big wall in front of that prevents it from getting access to the system. Windows Store apps limit what an app has access to, right? So you don't get access to the system. But you can get access to certain system resources. So you could get access to maybe a GPS if the user opts in to allow that app to take advantage of that technology. But the user has a lot of control in what they can allow the app to have access to. There's basic services that it automatically needs access to, but things like your location, like GPS setting, that type of stuff, the app will request that you give it to permission. So you're very familiar with this on Android and iOS. So this is now also in Windows. One thing that sets Windows apart, though, is app-to-app interoperability is very different than what you see on these other OSs. They're very limited in the ability to communicate with each other, or that just isn't allowed. With Windows 8, we've got a great model to allow apps share their capability with other apps, and that's something that's unique in some respects to our platform. You're familiar with Smart Screen, so basically app reputation, anti-phishing, that's all in the box. The big headline here is Smart Screen technology, which used to be an IE feature, at least for the app reputation side of things, is now built into Windows Core itself. So whether you're using IE or Firefox or Chrome, that great app reputation service, which by the way blocks 95% of malware just by itself with no anti-malware solution, 95% of the stuff out there is getting blocked based on the data we have just with Smart Screen. That now protects you also on any browser. So that's, I think, a big deal. I think it kind of speaks to our mentality about security. This feature here at the bottom is very interesting, and it's new for Windows 8. It doesn't have the best name. Provable Pc Health is about as boring a name as it can get, so we're going to see if we can work on that. But basically what this is a cloud-based service that augments your local anti-malware solution. The problem that you have with a local anti-malware solution is if you get a really nasty virus, one where they're able to compromise maybe a Microsoft certificate or something that's part of the boot process, if they are able to compromise our systems in some way, you might have something there. And we're talking about very, very high level of sophistication here, right? But we can't assume that UFI and Trusted Boot keep us safe. We need another layer. And that can only happen when you have a remote cloud service analyzing the PC. So we mentioned earlier about measured boot, and measured boot giving us integrity measurements of all the components, the UFI firmware, the OS loader, etc. Right? Wave Systems takes advantage of that in the remote attestation service. But Microsoft, until Provable Pc Health, had nothing in this area. What we're doing with Provable Pc Health is that measured boot data can be harvested, can be analyzed by the cloud, and if we ever see a bootloader that maybe has our signature, but doesn't look like anything we've ever shipped, we're going to know that somebody has done something very, very crafty, something like a Flame type V2 type of thing. And we'll be able to detect that immediately, and we'll be able to initiate a remediation process, would help the user reclaim the PC, and maybe even reclaim their MSA account or other accounts if they've potentially been compromised. We'll be analyzing the types of things that we discover on these PCs. So if we find, let's say, a keylogger on the PC, we're like, hey, you know what? Keyloggers can steal your password. We will let you know that, hey, you should be resetting passwords on all your accounts out there that you may have used. So this is something I think it's kind of unique. It is a cloud-based service again. It does not have enterprise management capabilities. I want to be really clear on that. It's really optimized today for the consumer scenario. So I think it's great for BYOD because you don't manage those devices as richly. But this is going to help keep those devices that you don't have a lot of control on right now more secure than they've ever been. In the future, I know what your feedback is. Well, give me a management system so that when you detect something in the cloud, I can find out about it and I can remediate it in my way. We don't have that today. We know the feedback's there, and so we're definitely thinking about that futuristically, but we don't have any announcements on that. But that's the natural progression. This capability is not to be confused with remote attestation. Just want to be really clear about that. We are leveraging measured boot data, but this is not a remote attestation service. It's really an augmentation to your anti-malware solution. So pretty cool, I think, and I would recommend run this anyway in your corporate PC. Seriously consider it. I know you can't manage it, but this is going to detect malware that none of your solutions very likely can detect because you just don't have the data that we have about what versions of OS loaders we've shipped and what they look like. So seriously consider it. These are the features here that leverage TCG technologies. ALSR is using TPM for entropy, UFI, of course, measured boot using TPM, Provable Pc Health using TPM for its measured boot data. So again, extensive use of TCG technologies. So last area here is protecting sensitive data. We've had great solution with Bitlocker in Windows for a really long time. It's been in enterprise only and also on professional. With Windows 8, we moved it from enterprise only as it was on 7. It now is in professional, so small businesses can use it. Even consumers can use it. But that's really not good enough in our view. Really, I think that encryption is a fundamental. Anything that has sensitive information, personal information, should be protected. And so device encryption, which was shipped with RT and also on Windows Phone 8, has now been included in every edition of Windows. So out of the box, when you deploy a new instance of Windows, out of the box, unless you decide to turn it off, it will be encrypted automatically using device encryption. If you want to use a third-party technology instead, you can do that. You can turn this off, but the native default behavior is to do this. There's one caveat to it, which is it requires Instant Go, or formerly known as connected standby technology. And so it needs to have TPM, in other words, it needs to have UFI, and it has to be certified for connected standby, which has a number of other attributes related to performance that will give us confidence that when we put device encryption on this PC that we know it's going to not cripple the PC. There's a lot of low-end devices that maybe don't have the I/O or even maybe the perf to do encryption, and so we don't want to just put it on every device and ruin somebody's experience. It really needs that technology that we know is there in connected standby. Instant Go. Instant Go, incidentally, really has just been on tablets at this point. So you know, Surface RT was connected standby. A number of others are as well. Because of Haswell, some of the work that AMD is doing, technologies like TrustZone and Platform Trust Technology showing up on a broader range of devices and becoming cost-effective, we're now going to see connected standby probably trickle down into laptop space in 2014. And maybe even all-in-ones, and maybe even theoretically in desktops, but I think we'll see it definitely on laptops, all-in-ones in 2014. And in 2015, I would expect that technologies like Instant Go are become pretty pervasive. They may still be on premium devices. We'll see what the OEMs can do about getting the cost down on them, but it's going to become pretty widespread. So if I want to go from device encryption, so let's imagine I get one of these great devices and it's already encrypted with Bitlocker, or excuse me, device encryption, but you want to centrally manage it. You don't need to decrypt and re-encrypt the drive with Bitlocker. You can just automatically kind of take ownership of it by simply adding additional Bitlocker capabilities on top. So if you want to harvest, let's say, the recovery key, the second you harvest the recovery key using Bitlocker code, it effectively goes into a Bitlocker mode. So there's no conversion, no difficulty in getting from device encryption to Bitlocker. It really happens as soon as you start using Bitlocker capability on top of it. So this is pretty cool. And then here's an announcement actually for this specific audience, is something we snuck in to Windows 8.1 that I think that this audience will be very excited about, is Bitlocker now is a great FIPS compliant option. On Windows 7 and Windows 8, you could get to FIPS compliant mode. You would use DRA, maybe you'd use startup key, and you would deal with a lot of pain, right? So provisioning DRA in a recovery scenario is kind of a nightmare. You've got to bring that box back in and whatnot. The recovery key password, which non-FIPS customers have been enjoying, which allows you to go to maybe a website and get that recovery key, and the user can unlock the volume and then reset their PIN or do whatever is necessary, was derived using a non-FIPS compliant algorithm. Well, with Windows 8.1, guess what? There's a new FIPS compliant algorithm we could use, and we apply that now to the recovery key password. So now, every single, basically automatically, every new Windows 8.1 device that you encrypt will automatically be in a FIPS compliant mode, assuming you're using maybe TPM plus a recovery key password, or TPM plus PIN with a recovery key password. The recovery key password is what's going to get you there. And so this is super easy to use. It addresses, I think, all the pain points that a lot of you have told us about. So so this is kind of effectively a new announcement that we're making here today. So last area here is about protecting data on devices. So today what happens is you have data on a device, and if it's a bring your own device type scenario, we're not managing it closely, you haven't provisioned maybe some sort of DLP solution to it, what happens, of course, is you lose control of the data very quickly. Once it lands on this unmanaged device, it could be leaking. If the relationship between you and the user has this device ends, your data is still there, etc. So what we've added is a capability that's selective wipe capability, which is kind of an industry term. We call it remote business data removal, and this gives you the ability basically to revoke access to data that happens to be on devices. So when the relationship ends between you and the user, you can use the OMA-DM protocol that an MDM might use, or Intune or whatever, and say, I'd like to initiate remote selective wipe on this particular device, and then the data the keys that are used to encrypt the data will be destroyed permanently, so the data will become inaccessible. And if the app that uses that data, let's say it's your mail app, decides to delete the data, it will be deleted as well. We don't delete the data in all cases, because you can imagine maybe some of that data is actually being shared in the cloud, right? So if I delete the data local on the host, I'm deleting in the cloud, and that's a problem. So it's up to the app to decide, what makes sense from a data perspective. Is it just revoking access permanently, right? We're talking about encrypted data with no keys anymore, or do I want to delete the keys and also delete the data? So each app will do it a little differently. There are two apps in Windows 8.1 that take advantage of this. There's the mail app that you're familiar with. So our mail client takes advantage of this. It deletes the data and the keys, obviously. And then there's a feature called Work Folders, which is basically a file replication service that you can use for managed or unmanaged devices. And it will revoke access to the key, or delete the key, so that access to the data is forever denied. So pretty cool new capability there that we've added in Windows 8.1. So which technology using TCG? Obviously, Bitlocker and device encryption is the one in the slide here. So that pretty much covers everything in Windows 8 and 8.1 in the very, very short time I had. I think I might have even gone long. But anyways, thank you for coming and listening to the presentation. I hope that it provided you some new insight on what we have in 8.1. If we have time for questions now, I can take some, or you can meet me in the back. But I'll stay up here for a few minutes until they kick me off at least. Question there in the back. Yeah, so historically the recovery keys for Bitlocker were stored in Active Directory in clear text. Are you saying that will no longer be the case? Not saying that. So the keys would be still stored in clear text in AD if you choose to put them there. What we recommend instead is that you use a product like MBAM. Or Wave Systems, I believe, they also manage Bitlocker, so they have their own way of harvesting that key and securing the key in their data store. So MBAM is our answer for that problem. Yeah. Any more questions?
I just wanted to say that your comment about sipping from a fire hose, was an understatement.
Was it? Okay. Well, I hope that some of it landed.
Is there a longer version?
There is. Actually, you can go to channel 9, and I have 2 presentations. One's solely focused on 8. It's 1 hour. And then one's solely focused on 8.1. That's another hour. So you can take the 35 minutes or whatever we took here and do 2 hours of it, if you want to hear me more. Great. Any more questions? Is anybody excited about the FIPS compliant protector? Okay. Good. Because we built this for some of our military, was really putting the hammer on us on this, and I'm not sure if that's you, but anyway, we built this for them and others as well. Great. Well, anyway, if any questions come up afterwards, I'll be in the booth over there, and so just grab me. I'd love to talk to you some more. I'd love to hear, for any of you who are deploying Windows 8, I'd like to know what security features you're using. Are you using virtual cards, smart cards, or others? So come by just to let me know what you're doing. I'd love to hear that feedback as well. All right, thank you.